Okay, so this video is a selection of questions from the physicsandmathstutor.com Vectors FP1 selection of questions. First look at question 3. So we've got a figure 1 shows sketch of a solid doorstop made of wood. Doorstop models a tetrahedron, so it's a tetrahedron. Given points A, vertices A, B, C, D. From there, triangle A, B, C. Okay, so we know the area of the triangle. We're going to have to do half magnitude AB cross with AC. What we're looking for. Let's first do AB cross with AC. So we do the determinant. This is to find the vector. So the vector AB, B minus A, is just 4, 0, minus 2. And then the vector AC, C minus A, is going to be the vector 2, 9, minus 1. If we work that out, so I'm going to get 18I. My J component is looking like 0, because it's minus 4. Add 4, yeah, 0. My K component is going to be 36K. Okay, let's so that's my vector. So I'm doing half of the magnitude of that. So I'm doing half root 18 squared plus 36 squared. This should be the area. Get 9 root 5. Decimal 3 sig fig is 20.1. So it should be 20.12 centimetres. A bit neater. 20.1 centimetres squared. That's the first one done. Volume, so obviously now, so I need the vector AB cross A. You see the formula? Remember tetrahedron. Now doing a sixth. Doesn't matter which vector I do here. Let's do CD. Yeah. So then I'm going to dot vector CD with my AB cross AC. Like so. Okay, makes sense. Right, okay, so what am I doing? So I'm doing a sixth magnitude, that's just in case it didn't get negative. So the vector CD, D minus C, is looking like, what's it looking like? It's looking like 1 minus 2. So 1 minus 2 and D minus 3. We're simply dotting that. Yeah, a bit here. Simply dotting that with the vector we found originally, which is this 18, 0, 36. That should give him a volume. Okay, so do I get, remember the magnitude only if it's negative, because we have negative volume. So we get half, sorry, a sixth rather. I get half from 6. Tetrahedron. What do I get? So I get 18 plus 36, lots of D minus 3 effectively. Yeah. Now I know that equals 21. They tell me in the question 21. So 21 equals a sixth. Bit neat on. Sixth of 18. 36 D minus 3s. It's a little bit of rearranging. So 21 times 6. 21 times 6 is 126. Take away your 18. Divide by your 36. Yeah, it gives you 3. So basically 3 equals D minus 3. So D has to be 6. D should be 6. Let's check that. There's your first one, the area 20.1. And there's your D6. Okay, so move on to question 4. Quite interesting. Figure 3 shows solid display stand with parallel triangular face A, B, C, and D, F. Okay. Triangle DF Yeah, similar to that's yeah. Okay, so we're given A, B, C. Okay, show the area of the triangle. So we're going to basically show. Need to focus on this first. Try and find the area of that, and we're going to try and do some volume tetrahedron. Okay, so that should be straightforward. That's just going to be half DE cross with DF. Okay. Let's do the cross then. So IJK, again determinant. So DE, E minus D, effectively. So -4, 3, and 1. That is a -4. Okay. DF, so F minus D is -1, 5, and 2. Right, so what is that then? So I think 6 minus 5 is just I. The J is going to be, let's check this, it looks like -7J. And then K is looking like, yeah, -17K. Okay, so we're doing a half of the magnitude of that. So each one a half square root 1 squared plus 7 squared plus 17 squared, which is a half root 1 plus 49. 17 squared's 289. Yeah, that just adds to 339. That's quite straightforward. First bit's done. Right, now what I need to do here then, guys, what's going on here is basically, let's just get rid of that. Go on that now. So we're going to make a tetrahedron clearly. Yeah, with this point, like, let's call that point there. Let's do that again, sorry. Just build a triangle, really. Yeah, that's what you're doing. You're making a tetrahedron. Okay, like so. Let's call that G. So that's just the point X, Y, Z. Now, because they're telling me that the triangles are similar, I just need to find the scale factor. I can find the scale factor if I just look at DE and AB. That's going to tell me the scale factor, isn't it? I already know the vector DE. Yeah. DE is the vector -4, 3, 1. So I'm trying to find the scale factor. If I look at AB, B minus A, yeah, I get -8, 6, and 2, yeah. So scale factor clearly 2. So we can do scale factor cubed for volume, which is 8. If I find so what I'm going to do, to make it clear, I'm going to find the volume of the small tetrahedron, times by 8 will give me the big tetrahedron and just take away the little one, okay? That's what I'm going to do. So what I need to do, I'm going to do is try making that here 6. I'm going to do DG and dot that with my vector I've already found, which is -17. Yeah, and obviously take the magnitude being positive. That will give me the small volume times by 8 and take away the original. Nice question, this one. Okay, let's make some room. Now my scale factor I'm going to use is 8. Okay. Right, so I need to find point G. Now, I know, yeah, that's what I'm going to do. So you've got so basically G lies on the line. Think of the line A, think of AD extended, so they're on the same straight line, obviously. Okay, so I can find the equation of the line AD, and G must be on that line. Yeah. Another point out, I've got the parallel vector AD, so the line ADG effectively. So you know that's going to be, so that point lies on this line. So it's going to be point A, which is just 3 minus 3, 1. Yeah, plus some constant of the vector AD. Yeah, which is D minus A, which is just -1 2, 7. Yeah, because all I'm doing, I'm going from here to here. That's what I'm trying to do. Can you see that? Yeah, and I'm using that vector AD. I'm using a multiple of that vector AD to get there, aren't I? So that makes sense. So start at A, get to G by using a multiple of that vector. That's what we're doing, guys. That's the equation of a line. Okay. Now I can do that the other direction as well. So I can. The point of this is it's like a simultaneous equation, really. I can do that going from CFG as well. So I can start at C, which is the 0.175, and I can use some multiple of the vector CF, so F minus C, which is just going to be 0, which is good, always good, and minus 3 and 5. Yeah, so again, starting from here, trying to get to here, so start with C and use some multiple of vector CF to get there, don't I? That's what I do. That's what I'm doing the equation line. Okay, now this is good because straight away, if I look at, maybe I should write them as column vectors, it's easy to see. See, I've got 3 minus lambda. Yeah, now because straight away, look guys, the I-component's 1, can you see, because there's no mu, I know straight away that lambda must be 2, because 3 minus 2 is 1. So I know lambda is 2, therefore that's going to get me my point that I need. So it's going to be, start with 1, lambda's 2, got minus 3 plus 2 is minus 3 plus 4 is 1. And then 1 plus 14 is 15. So that's my point. G is my point, 1, 1, 15. You can check that in the other one if you want to. Just make that a bit clearer. So first it's 1. Obviously you've got 7 minus 3 mu, which would equate to 1. Therefore mu is 2. If mu is 2, you can clearly see. You get 15, 1, 1, 15, either way. Okay, so that's good. So now what we're doing, we're coming back down here, and we're going to do a sixth of the vector dg. So dg is g minus d, obviously. G minus d, yeah. So that's going to be my 1, 1, 15 minus my d. So 1 minus 1, 2, and 7. If I just dot that with the vector I already had 1, 7 minus 17, you see, should get my volume. So what do I get if I do this? Is what it says. There's a sixth. I get minus 1 plus 14 minus 7 17, which is just 119, isn't it? Yeah, 7 17 is 119. Take that away. That's a sixth of, so it's going to be 100. Yeah, so 14 minus 120 is minus 106. So it's a sixth of 106, which is 106 over 6, which is 53 over 3. So that is my volume of a small tetrahedron, my yellow tetrahedron. So 53 over 3, guys, is my, can you see that? My yellow tetrahedron, 53 over 3. So what do I need to do now? Well, quite simply, I just times that by my 8 to get my big tetrahedron. 53 times 8 is 424. Yeah, that's the big one, all of it pasted together. So, for example, what do I mean by that? Just to show you. I mean the whole thing. Yeah. So now if I take away my little one, my yellow one, okay, I must have the one I'm left with. 53 over 3. 424 minus 53 is 371 over 3. So 371 over 3, guys, will just be the volume of what I wanted. This door stand, display stand rather. That will be that value there. Okay, so it's an interesting question, that one. 371/3 should be the answer, I'm hoping. Yeah, there's your 371/3, guys, there. 371/3. Okay, so question 9. Interesting. Okay, so yeah, tetrahedron, A, B, C, D. Plane equation cuts the tetrahedron in 2 pieces. Okay, right. So first thing to say is points M, N, and P. We know the Z value will be 0 for each one, wouldn't we? Okay, so it's interesting. So what we have to do then, where to do this question is, so let's do M. So it's X, Y, Z, obviously. Now we know it lies on the line AB, don't we? That's what it lies on. Okay, so we know that we start with A, which is the point 32 minus 4. Yeah, and again, what's happening, guys, to get from here to here, I'm just using some multiple of the vector AB. Start A, use some multiple of the vector AB to get to M. That's what you do in the equation line, aren't we? Yeah, so let's go lambda the vector A to B, AB, which is B minus A. So it's going to be 6. B minus A 6, so minus 6. And 6 again, isn't it? I think. Yeah. Okay. That's good. Yeah. And obviously, we know, guys, that the Z component is 0. That's going to tell my lambda straight away. Okay, so we know, don't we, that this Z component here has to be 0. That's going to work out lambda. So we know minus 4. You know, minus 4 plus 6 lambda has to be 0. So lambda has to be 4/6. Let's leave it at 6. That's not simple because I've got 6 there. Okay, so that's straightforward now to get a point. My Z value is going to be 0, bottom. So look at my X, guys. I've got 6 lambdas, 4. 3 plus 4 is 7. 7. And then minus 6 lambdas, minus 4. 2 minus 4 is minus 2. So that's your point M. Okay? Good. So your point M. I'm just going to write this on here, actually, I think. I'm going to get some room in a bit. So 7 minus 2, 0. Yeah, perfect. I'm just going to do the same. We're just going to do the same, guys, for the other points now. Yeah. Because now the Z is always 0. So let's do the same way. Let's do N. Again, we're starting at A, obviously. And then we're doing, let's use lambda. I'll use lambda again. Some multiple now the vector AC. That's what we're doing. We're starting at A, some multiple vector AC. It makes sense. So C minus A, guys. So minus 9. Minus 12. And 12, yeah. And again, just that bottom bit being 0 will tell me everything I need to know. So I know this is 0 on the bottom. Okay, so I know that 12 lambda minus 4 is 0. So the lambda's a third, guys. Okay, so we just put that in. So we look at the x value. Third of minus 9 is minus 3. 3 minus 3 is 0. So that's definitely going to be 0. Now, third of minus 12 is minus 4. 2 minus 4 is minus 2. So I get n to be 0 minus 2, 0. Just put, just, so 0 minus 2, 0. Let's do it like that, I think it's clearer. Let's make this clear. 0 minus 2, 0, big 0. Yeah, it's fine. And then what do we say? M was, what was M? 7 minus 2 zeros. So not that clear there. Make it a bit more clear, guys. So we said this was 7 minus 2 0. Good. Right, so finally one's P. Again, we're just doing the same things. It's quite nice. And change to P. That right now. P, we're going to do lambda. Obviously, this time the line's AD, vector AD. So D minus A, minus 7, minus 7, and 14. So again, we know the bottom number is 0. That's going to tell me my lambda, isn't it? So 14 lambda minus 4 is 0. So lambda is 4 over 14. We've got 7, so let's go 2 over 7. Okay, it's 2 7. So x is some times minus 2, so 3 minus 2 is 1. That should be 1. And if you look at the next one, guys, 2 minus 2 is 0. So point P is 1 0 0. Interesting. So they should be correct, guys. Yeah, a bit neater. Okay, so that's the first part done. Yeah. Right, it's then telling me the area of M, well, that's easy now. The area of MMP is going to be straightforward now. So I want the area, guys, of this triangle here, straightforward. So we're going to do a half. Let's just do MN cross with MP. Right, so cross product of MN and MP. So MN is obviously N minus determinant, sorry, N minus M. So it's going to be minus 7, 0, and 0. We like zeros, makes it very easy. And then MP is P minus M. So minus 6. P minus M, so it's going to be 2 and 0. Okay, this is straightforward, guys. Really straightforward because there's no I component clearly. There's actually no J component. It's only a K component, which is going to be minus 14. Straightforward. So that's got size 14. Half of 14 is obviously 7. So the area of that triangle definitely is going to be 7, 100%. That's straightforward. Right, the volume now. So they only want B, C, D. Okay, yeah, that's fine. So they only want, guys, the bit this volume. Can you say? So what we're going to do, we're just going to do the big tetrahedron minus a small tetrahedron, aren't we? So minus the green one. Yeah, yellow minus big thing minus that green one. Yeah, all of it minus the green. Okay, so let's do the small tetrahedron first. Make it clear what I'm doing. So let's just do this first, this tetrahedron. Yeah, so we know what we're doing, don't we, for this one? So we're doing 6. This should be straightforward, guys. 6. We're gonna have to do NA. Excellent. Oh, excuse me. Yeah, it doesn't matter what I do. Let's just do NA. So NA, dot that, don't I? With my vector that I've already found in the previous part, which is 0, 0 minus 14, which is going to be really nice. Okay. So I'm going to get a 6th. So the vector n to a, which is obviously a minus n, should be straightforward. Should be 3 So a minus n, yeah. So I'm doing 4, and obviously minus 4. So I'm just going to dot that with my 0, 0 minus 14. So I need to worry about the z bits, don't we? So it's just going to be quite simply a sixth of 4 14s, which is 56. So it's going to be 56 over 6, which is 28 over 3. Yeah, 28 over 3. So 28 over 3 is the yellow tetrahedron. Yeah, the yellow tetrahedron. Let's just highlight that yellow. Okay, so now what I'm going to do, I'm going to find the volume, guys, of the big tetrahedron. This thing here. Okay, then do the difference would be my answer, wouldn't it? Yeah, can you see that? Okay, so what do I need? So obviously I'm going to need the triangle BCD, i.e. this triangle, in vector form. Yeah, that's the first thing I need. So what I'm going to do here, guys, I'm going to have to do BC cross with BD. Yeah, I need this vector, definitely this vector. So let's work this out, guys. IJK, so BC, so C minus B, yeah, is minus 15. Yeah, that makes sense. So C minus B, yeah, so it's going to be minus 6, and it's going to be 6. Right, laser 6, guys. BD, so D minus B. D minus B is going to be minus 13. D minus B is minus 13. Minus 1. And 8. Okay, so need this vector, guys. Right, so let's work this out then. So my I component is minus 48. So minus 48 plus 6 is minus 42. Yeah. The J component, let's work this out, my J component. So it's minus 120. Yeah, I'm just work this out, guys. Minus 120 plus 6 times 13. I've got to change signs, so it should be plus 42J. Then my Z component, my K component rather, is quite simply 15 minus 6 times 13 is minus 63K. Okay, so this is good now. So I know I've got to do, yes, so CA dotted with that vector, minus 42, 42 minus 63. This will give me, guys, the big tetrahedron. Let's do the difference then. Nice. Okay, so let's work this out. So 6. Put the magnitude size because it can't be negative, guys. That's all that it really is. Okay. Right, what do I need? I need CA. CA is A minus C. So it's going to be 7. Let's work this out. CA. Excuse me. Right, I'm going. So CA and A minus C is Yeah, it has to be 7. Oh, sorry, A minus C. Sorry, I was going to look at D. A minus C is definitely 9, isn't it? So it should be 9, 12, minus 12. Yeah, that's definitely right. I need to look at the wrong one. So 9, 12, minus 12. Good. Right, I dot that with my minus 42. 42 minus 63. Let's try and fit it onto one slide, guys. Okay, so let's work this out now. So 9 times 42, got a negative, so minus 378, plus 12 times 42. I could have just done 3 times 42, couldn't I really? 126. And it's going to be positive anyway, so plus 12 times 63 is 882. Yeah, so I've got 882 over 6. Does it divide by 6? Yes, it does. 147. Good. So 147, guys, is that whole tetrahedron. Yeah, whole tetrahedron. Okay, so what do I want? I only want this bit. So that, the orange, must be the green minus the yellow. That should be my answer. So let's change to normal pen. So it should be 147. Yeah, 882 divided by 6 is 147. Yeah, 882 by 6 definitely 147. 147 minus 28 over 3. Right, my calculator. 413 over 3. 413 over 3 should be my final answer. That is a 3. 413. A bit neater. It should be answer, guys. Final answer 413 over 3. Yes. 413 over 3. Perfect. Okay, let's move on to question 11. Working. Okay, so direction cosines, guys. So respect the fixed origin, they give the equation a line. The point A lies on line. That's important. Such that direction cosines are given there. Well, the first thing to say, guys, is this 3 over 7. So this is telling me 3 over 7 equals x over root x squared plus y squared plus z squared. That's the way it works. Then because that's positive, that means my x must be positive. So the point A, which is x, y, z, my x has to be positive, guys. Cancel both in z. Now, I would do first, obviously, if you manage to probably do this question, I'll just cross multiply first. So we get 3 root, then we're trying to find x, y, and z to find the point A. X squared plus y squared plus z squared, a bit neater. Yeah. That equals 7x. Square both sides. You get 9 lots of x squared plus y squared plus z squared equals 49x squared. Okay. What can I do? Let's move all of this actually onto there. So I get 0. So I get 40x squared minus 9y squared minus 9z squared must equal 0. I'm trying to find x, y, and z, remember, okay? Now, what I'm going to do now, because the point A lies on the line, so what I'm going to do is replace my r with my x, y, z, okay? So I know, just had to put my pen, that x minus 12, bit neater, x minus 12, yeah, y minus 16, and z plus 8. If I cross that with the vector 9, 6, 2, has to give me 0. So that's what I'm going to do. So I, j, k, I forgot, I've got x minus 12. Yeah, I've got y minus 16. I've got z plus 8. And I've obviously got 9, 6, 2. Okay, so what I'm going to try and do is basically forget in terms of one. I need to get it in terms of one variable basically. So if I look at the k's, i.e. by going there and there, what do I get? So I get 6 lots of x minus 12 minus 9 lots of y minus 16 equals 0. So 6x minus 9y, what will that equal? So 6, 12, 7, calculator, 72, minus 9 times 16, isn't it? So it's minus 72. And divide by 3, 2x minus 3y is going to be minus 24, isn't it? Okay. So move this over. I can say x equals 3y minus 24 over 2. So I've got x in terms of y. Yeah? So if I get z in terms of y, then I can just put that into that equation and find my y basically and then do it from there. That's what I'm going to do this question. Okay, right. Let's go back to my determinant. So I want to get y and z together. Let's get y and z together. What can I do? I can do the i's, can't I? Yeah, that's what I want to do. Okay, so let's do it this way. So I've got 2y minus 16 minus 6 lots of z plus 8 has to be 0. I know the sign changed, but it won't affect it here. Don't worry about that, guys. So 2y minus 32 minus 6z minus 48 is 0. 2y minus 6z is going to be 48 32, which is going to be 80. Divided by 2, y minus 3z, 40. Now I want z in terms of y, so swap these two. So z equals y minus 40 over 3. Yeah, so I'm going to do it. Okay. Right, so let's make some room now. Try and get this done. Remember trying to find x, y, and z to get the point. I remember that my x has to be positive. So the direction cosine is positive. Okay, so let's leave these on. I'm interested in this equation now. Should be able to do it from here. Okay. Right, see if we can do it from here then. So what have I got? So I've got 40. Got some x squared in terms of y now. So I've got 3y minus 24 over 2 all squared. Minus my 9y squared just stays as it is. Minus 9 lots of z squared, which is y minus 40 over 3 all squared. Yeah, equals 0. Right, look at the first one. 2 squared is 4, so cancel to get 10. So I get 10. If I expand that, I get 9y squared. Right, 24 times 3 times 2 is minus 144y. Makes it a little bit neater. And 24 squared is 576. Minus 9y squared. No, 3 squared is 9, they cancel. That's good. So you get minus y squared minus 80y plus 1600, isn't it? Yeah, equals 0. Right, okay, let's simplify this then now. So altogether I've got 90 minus 10, so 80y squareds. Okay, so that deals with that one, that one, that one. My y's, I've got minus 1440 plus 80 gives me y minus 1360 y's. That's that one done. The constant term is going to be 5760 minus 1600, which is plus 60 equals 0. I'm sure we can simplify that, guys, but actually we can divide by, let's might as well just divide by 10, to be honest with you. It doesn't really matter. Let's just cancel the zeros. Makes sense. So we get 8y squared minus 136y plus 416 is 0. Let's put into our calculator. It should give me 2 values of y. Okay, let's put into our calculator. Solve. So I've got 8 minus 136, and I've got 416. Okay, so my calculator is giving me y as 13, okay, or 4, which is interesting. Now remember, x has to be positive, guys. The x is the important one, okay? So from there, x is, if y is 13, let's go back. So 3 times 13 is 39, minus 24 is 15 over 2. So x is 15 over 2, yeah, it's positive. If y is 4, clearly 12 minus 24 is minus 12, divided by 3 divided by 2 rather is minus 6. So it definitely cannot be that one. So it tells me that y has to be 13, so go to z, 13 minus 40, divided by 3 is minus 9. So I know that a has to be, it should be anyway, 15 over 2, 13 and minus 9. And just to check this from, before, guys, if you do 15 over 2 divided by root 15 over 2 squared plus 13 squared plus 9 squared, so I can do that a bit neater. It's 15 over 2 squared. If you put into calculator, you will see you get 3 over 7. Okay, but the important thing was that x has to be positive, because direction cosine is positive. So it should be 15 over 2, 13 minus 9. Yeah, there it is, guys.